today my topic which I am going to discuss is UML diagrams. And in UML diagrams, basically I am going to discuss about the two diagrams that are most important, and sequence and activity diagram, which is I am going to discuss. So first one is a sequence diagram. Basically, as its name implies, that sequence diagram is basically used to represent the sequences of the real world problems. For example, we can say that if we want to draw a diagram for a ticket reservation system, that what the sequence of tasks which a person will going to perform, that will be considered under the sequence diagram, with each and every sequencing of the messages or the data which is going to be passed during the whole process. So we can say that it is an interaction diagram, basically, which tells you how and when the objects of the system communicates with each other by passing the simple messages. And in short, we can also say that it is going to show the sequences of the messages, which kinds of messages and what are the messages which is going to be communicated between the objects or between the different objects. That whole sequencing comes under the sequence diagram. Now, making of sequence diagram. So, the first symbol or first activity which we can use while we are going to draw the sequence diagram is actor. Basically, it represents the role of the user, that what particular role a particular user is going to be perform, or any other entity that is external to the system, but it interacts with the systems. So, that is the first symbol or first representation which is going to be used in sequence diagram. And the symbol of this particular representation is this. Just like in use case diagram, we are having this symbol, and same in use case diagram also, this symbol represents the actor. Okay. Now, next symbol is lifeline. Basically, it starts with the rectangle label shape, or it starts with the actor also, and dotted line goes downwards, which shows the time, up to which time that particular object is going to be get interacted or going to be get activated. That particular dotted line is showing the lifeline of that particular objects. Okay. So, till whatever the time or till whatever the processes which are going to be taken in the sequence diagram, basically the lifeline starts with the rectangle label shape figure and also with the actors, and that particular dotted line goes downwards up till and until the particular process or particular object is going to be activated in that particular process. After that, it will get abort. Next one is activation. That particular thin line over the dotted line of the lifeline, it represents the activation. That particular object or particular layer is going to be get activated up to which time. Okay. So, between the or over the dotted line which shows the lifeline, we have an thin rectangle shape diagram which basically represents the activations, or basically it represents the period in which an element is going to perform an action. Okay. The next one is call message. So, this is the message which we send from one active lifeline to another active lifeline objects. Just like here in this given example, there are two different objects, one is source and the second one is target, and these are the messages which are going to be communicated between these two objects. So, call messages basically simple, we can say that these are the simple messages which are going to be communicated between the different objects. So, here in this given example, we are having two objects, source and target. So, here from the particular source, the message is going to be passed as a parameter. Okay. After that, we are having a return message which is also in kind of parameter, and this is this dotted line. We can see here this dotted line which is coming back from the target to source. This dotted line basically represents the replay messages, and single arrow line represents the normal message which is going to be passed from one object to another as a simple message. Okay, as a simple call message, and that dotted line represents the acknowledgement kind of message or replay messages which are going to be sent from the target to the source objects. Next one is return message, which I had already told that when we send a call message from an object A to B, then the object B also replies, also acknowledges to A that he has that particular object has received that particular message. So basically the replay messages has a concept of acknowledgement kind of message. Okay, that means that particular target has received the message which is going to be communicated from the target, from the source A or from an object A. Now what are the self messages? The lifeline activation. This is the lifeline activation. When a lifeline activation sends the messages to itself only for some purpose or for something, then that particular message is known as self message. Okay, so lifeline, so self messages are basically those messages which are going to be transited to itself only, to that particular object only, or to that particular lifeline activation symbol only. Okay, so this is known as the self message. Now what are the duration of message? When we send a message from object A to B, for example, this is an object A and this is an object B. So object A represents the online bookstore and the object B is representing the database. So when we are going to send a message from object A to B and it take a little bit time to respond back, then we will show these kind of cases with the duration messages, just like in this way. Just that this particular lifeline activation has sent a message or has sent a query to the database, and till up to which time that particular online bookstore is not receiving the reply. Okay, so this particular thing is representing the duration of message, that from this duration up to this duration, that particular query and response kind of process or kind of communication takes place between these two objects. So whenever we are going to send a message from one object to another, then if in any case it takes a little bit time to respond back, then we will show the kind of cases with these kind of symbols, just like duration messages, that this particular occurrence of event has taken this period or this duration of time. Now create message. On the base of a message, new lifeline bonds. This is what we can create message system. Just like in this particular example, we have a simple lifeline activation which is instant created. Okay, so that particular instantly creation of a message is known as create message. Okay, new lifeline, whenever during any process or during any diagram representation, any new lifeline bonds, then from that lifeline activation, whatever the message is going to be passed from the different objects from the another to the another object, then that particular kind of message is known as create message. Now this is the one example in which we can have a power control, or one object is power control unit and the another one is electrical power controller. So this is the start of the event or start of the process. So first of all, what we do, this particular 1.0 is showing the sequences of the messages which are going to take place in this particular example. So in sequence diagram, it is also one of the most important point that you have to define the sequences of the occurrence of the events or occurrence of the messages which are going to be take place between the different objects. So this particular numbering represents the sequencing of the messages. So 1.0, it means it is first message or first communication which is going to be start. So in the first event, we are going to start the vehicle. After that, this particular symbol represents the lifeline activation, and from that particular lifeline activation, that power control unit has started. So it get enabled, and when it get enabled, then the electrical power controller will receive the message that it has been enabled. Then it again reply. For this particular message, it will send the reply which shows with the dotted lines that it is also ready. Now after receiving this acknowledgement, the vehicle will going to be get a start. Now in the next example, we have two objects. This is computer and this is the server. This is source, this is target. So first of all, we are going to check the mail. Then we are going to send unsent email to the server. Here we can see that this particular computer is going to be activated throughout the process. Okay, but that particular server is get activated, then again deactivated, then activated, then activated, and again activated. Means this can be the server can be for a particular point of time, the server can be deactivated, but the computer is going to be activated, that the lifeline of the computer is going to be activated throughout the program. So send unsent email. Okay, after that the computer is going to be sent new email, then that particular system will get the response. After that, new email, download email message will be going to be set to the server, and then delete old email. So this is simply the example in which we are going to have a process, or we are going to have a look over the how we are going to check the emails from computer to server. So this is the simple diagram which is going to explain this particular kind of sequences, that how we are going to check emails. So first of all, what we are going to do, we are sending the unsent emails, then we are sending a new emails, then we are going to delete the old emails. Now what are the synchronous and asynchronous synchronization in this particular sequence diagram? Basically in synchronous, whenever a client is going to make a request to the server, has to wait until he gets the response, which means synchronous call blocks the client until the operation completes. So here we can say that this is the user or the actor is sending a message exam, and then until now that particular actor is not going to have a reply from the particular server from the exam hall, then he or she has to wait for a particular period of time. So that's why we are saying that when synchronous, when a client makes a request to the server, he has to wait until he gets the response from here. So that particular synchronous kind of messages blocks the client until the operation completes, because the actor has to wait for this particular time until and unless it is going to have a response from the server. So in asynchronous, when a client makes a request to the server, he does not need to wait until he gets the responses, which means asynchronous call doesn't block the client until the operation completes. He is free to do other activities. Here we can say that the actor is going to upload the videos over the system, over the server, and also editing video title. So here we can see that in asynchronous messages, the actor or the user has the capability or has the freedom, has its freedom to do multiple tasks. But when we are going to see in the asynchronous messages, then the particular actor is going to be blocked until the operation completes fully. Okay. So synchronous messages typically represents the operations calls, send the messages and suspend the executions while waiting for the responses, and comparatively in asynchronous messages, we are having the send messages and proceed immediately without waiting for the return value. Okay. Here the notations are for synchronous messages, we are going to have a filled arrowhead, and for the asynchronous messages, we are having a open arrowhead. So in this particular example, these all are the synchronous messages, because they are having the responses for each and every messages. They are waiting for the responses until and unless the response is not receiving by the computer, it will not process another request. Now what are the lost and found messages in the sequence diagram? So lost messages are those messages where the sending event is known, but there is no receiving event. It is interpreted as if the message never reaches destination. So web client sent the self messages which was lost. Okay. So for lost messages, we are going to have and for found message, it is a message where the receiving event is known, but there is no sending event. So that symbol is, the same symbol is used, but the representation is somehow different. So it is interpreted as if the origin of the messages is outside the scope of the description. So that's why the representation is from the live. Here we are having the representation outside the lifeline activation, and here the representation is inside or incoming from inside the lifeline activation. So this is the basic difference between the lost and found messages. That in lost messages, sending event is known, but there is no receiving event, and here is no sending event and receiving event is known. So this is the basic difference between found and lost message. Now what is the combined fragment? Through the use of combined fragments, the user will be able to describe the number of traces in a compact and concise manner. So combined fragment may have various interaction constraints, also called guards in UML. Just like in activity diagram also we are having a guard, okay, just like controlling activity or controller. Guard play the role of controller. So these are the some combined fragments which are having its usage in the diagrams. First one is alternatives. So for alternatives we are going to have a alt, and for various options we are having an opt option. For iterations we are going to, for loops we are going to use iterations, break for break, and for parallel we are having a short form PAR, and for strict sequencing we are going to use the word strict, and weak sequencing, for weak sequencing we are going to have a word seek, SEQ, seek. For ignoring, same ignore word is used, and for assertion we are going to have a assert word. Now this is again the diagrams which are having their representations for all these guards. In the first diagram we can have a alt. In this particular diagram we have an opt parameter, and in this way, in this diagram we can see how the loop is going to be its usage in the sequence diagram. And then again when we are having to use the loop to execute exactly 10 times, then the representation is somehow in this way. Again when we are having a break command, then in this way we will use break in I sequence diagram. It reduces to the strict sequencing when the operands work on the ignore, get and set word or parameter, and this is an for assertion parameter. Now the second diagram is activity diagram. Basically we can say that it is a workflow diagram and flow chart to represent the flow of control among the different activities which are going to be occur in a system. So it's basically it's a pictorial representation of all the control which are going to be flow from one operation to another. So suppose if you want to make an algorithms for the authentication by the algorithms flow, you can show by activity diagram. For this algorithm you can easily show the activity diagram. With the help of activity diagram you can show this example. So the flow of operations can be sequential, branched or concurrent. So how we can show these operations in UML? Just we are going to discuss about this. So activity contains the activity nodes which could be action, object or controls. Activity parameters are displayed on the border and listed below. The activity names are parameter names or parameter types. So here in this particular authenticate user activity with two parameters. For example, if you are going to authenticate the user activity, okay. So we are what parameters we are going to have? We are having two parameters. What are these two parameters? Login ID and password, okay. Then only you are going to authenticate user or not, okay. So for this is a simple example in which we are going to authenticate the user activity. So for example, if the example is given that you have to authenticate the user activity, then authenticate user activity with the help of activity diagram. Then what you will do? You will first of all you will think about that how user can be authenticated. So the two parameters came into your mind that whenever we are going to log in, okay, in any website or in any apps, then we are going to put two inputs. That two inputs are login ID and password, okay. So this login ID and password are the basic inputs which are going to be fed to the start activity, okay. So whenever this particular symbol is going to that particular symbol is going to shows the end of the activity. It is a double circle and the first circle is black filled. So the activity symbols are the basic building blocks of an activity diagram, and usually we have a short descriptions of about the activity what they represent. So for representing the activity we are having this rectangle having an rounded sides, okay. So this symbol represents the activity, whatever the activities which are going to be take place in a particular diagram or in a particular process. The for flow of control we are having a filled arrow, okay, which is going to be representing the progressions of progressing the activity, directions of the progressing activities, how the activities are going to be flowed in that particular activity diagram. That particular solid line, basically we can say that solid line is used to represent the control of the flow. Next one is join node. join and fork node. These two nodes are very important. A join combines the two concurrent activities which are going to be take place in a particular example, in a particular system, in a flow of diagram. So join node is this particular is a join node, and it is taking the multiple or concurrent activities and giving a final output. So going fork node, just like fork, we can say here, we can see here that this representation is similar to the fork. So fork splits single activity flow into the two concurrent activities. Combine join node and fork node. If you are going to combine the join node and fork node, then this kind of representation we can have. So flow final node is a control final node that terminates a flow. It destroys all the tokens which are going to be arrived at it, but has no effect on the other flows in the activity. So this is a flow final node. What is the decision node? Just like a decision box, it is a control node which is going to accept the tokens on one or two incoming edges and selects the one outgoing edge from one or more outgoing flows. Decision node with 3 outgoing edges and else guard. This is also a decision node with 3. This is decision node with 2 outgoing edges with guards, and this is the decision node with 3 outgoing edges and else guard. Merge node is a control node that brings together the multiple incoming or alternative flows to accept single outgoing flow. But in merge node we can see that incoming alternate flows. So basic difference is that here we have multiple inputs, and when we are going to merge both we are going to combine both merge and decision node, then multiple inputs and multiple outputs can be seen here. And when we are having a single merge node, then what we can see? We can see here reverse of decision node. In decision node, single incoming node is there and multiple outputs are there, but in merge node multiple inputs are there and single output is getting out. So what are the activity edges? Basically the activity edges are notated by an open arrowhead line connecting the two activities, and edges can be named. However, the edges are not required to have an. This is an example of business flow activity to process the purchase order. So order is requested and then order is received. Now either the order is going to be accepted or rejected. So here we are having a decision node. So if the order is accepted, then which activity take place? Order fill. Okay. After that, we are having two options. So here this is a join node. Okay. So we are having two activities. We are having a single input, or this is a fork node. So we are having a single input and multiple outputs. So we are having two options: send invoice and ship order. Then invoice, then accept the payment, and in ship order we are having direct join operation. Here both the inputs are joined and we are going to reproduce the single output, that is the close order. So here this particular symbol is going to have a merge node. Okay, this is merging the two inputs and producing a single output, that is close order, because order is shipped and now the order is fully closed. Okay, so this is the complete process. This is the complete activity diagram which is going to show how the purchase of a particular order takes place. So in this particular diagram we can see that mostly all the notations of activity diagram takes place: fork, join, merge node, decision node, and what are the different activities, start and end node. Okay, so this diagram is the simple diagram which is showing that how the activities takes place in the particular process order example. Now this is the UML activity diagram which is going to describe the behavior of the purchase ticket, that how to purchase a ticket. So first of all, this is a computer, this is a ticket vendor machine, and this is a bank. There are three main actors which are going to play a role in this particular diagram. Okay, so first of all, when the process is start, then season is we are having first activity, that start season, request for the trip info, then provide the trip info, then process trip info, then when we are going to process trip info, then first activity, which first activity will take place, that request payment, then provide payment information, then process payment. When we are going to process payment, then we are having two options, that pay with cash, pay with card. So when we are going to pay with cash and when we are going to pay the card, so authorize the card payment, both are going to merge, and then the ticket will get dispensed. Get ticket, then paid with cash and with the changes, dispense the changes, get the changes, and then show that the particular has received the tickets, and then the particular message, thank you, or whatever the message you want to display, that particular message will get displayed and the complete process will get closed or end. So this is the end symbol. Okay. So that's all for today's lecture.